How is everybody doing today? Hey, there we go. It's about to make you do like a stand-up exercise or something. Be one of those people. So I'm Brian, as he said. I'm a core engineer at Docker. I'm also a maintainer on the open source project. I spend quite a bit of time in the storage subsystem, and I'll kind of tell you why here in a minute. But so to kind of go over what we're going to do, we're going to look at container and image storage and persistent storage. Now, these are two different things. I'll kind of get into the nitty-gritty of what these really are in just a minute, but I figure most of you don't know who I am. So I'll tell you a little bit about myself and why you should be listening to me. Hopefully, you think you should be listening to me by the end of this talk. I know a few people, but it looks like there's like 800 people in here. It's crazy. So I've actually been using Docker for about 3 years. At my previous job, I was deploying Docker, and I did it in production at 0.7. So I've been doing it for quite a while, and saw a lot of the early, rough edges around Docker. And how that kind of got started was a little interesting, kind of a pain in the butt. So one day I was deploying a new version of my Rails application. And this is a true story, not just some enterprisey story. I was deploying a new Rails application, and like just about any application deployment, it went to hell. I was working on this thing all day. It should have been fine, but like 10 minutes of work, and it went to like 24 hours of work. So I spent the whole day debugging, and basically what had happened is I was deploying Rails, which requires a YAML parser. Now, this YAML parser requires, for whatever reason, Java. I had to put the Rails YAML parser requires Java, and you'll find that out if you set up a brand new VM and try to set up Rails and what have you, and it breaks to pieces while you're trying to deploy something to production. It was a great day for me. So I spent the rest of that day, or pretty much not the rest of that day, more than that. From then on, for a couple of weeks, I was evaluating a few tools that can help me improve my deployments. I was already feeling kind of elite, like I was using Capistrano, which was pretty cool back then. But it turned out, even with Capistrano, I still had this issue. And I also had this issue where I was the head of IT / only person in IT. So everything from ops to software development, so that was my Rails application that I failed to deploy into production. Even in user support, I was doing all this stuff, and I kind of realized I didn't have anybody to lean on. Like when I had this problem, I didn't have anybody to lean on, and also if something happened to me, I got hit by a bus, there would be nobody to take care of the infrastructure, and the company would very likely die. If you are in this position, find somehow somebody to be able to lean on, someone to lean on, because you really, even no matter if you hate your job, you don't want your company to die. Like, it's horrible. If you do want your company to die, then change jobs, please. So, using Docker very early on, I found a lot of issues, both in how I was deploying or trying to deploy things, as well as issues with Docker. Yes, there were issues with Docker. I guess there's still some today. So I spent a lot of my time going through their code base, just trying to figure out what I was doing wrong, what Docker was doing wrong, or even just what the heck Docker was doing at all. Like, what was it doing with my volumes, and what should I expect it to do? What was broken versus what I had broken. And this is actually how I even learned Go, and it's how I got involved in maintaining the Docker project, essentially just going through the code base. So that's me. Hopefully you can know by now that I spent quite a bit of time actually in the storage subsystem itself, looking at both graph drivers and volumes and all this crazy stuff. So let's go ahead and talk about image and container storage. Now, this is different from persistent storage, where persistent storage, you want things to stay around. Image and container storage, you want things to stay around, but in a different way. So what this is these are what we call the storage drivers in Docker, or internally in the code base, these are called the graph drivers. Now what these do is when you do a Docker pull or a Docker run, these are going to Docker Hub or whatever registry and pulling down an image. That image consists of a set of file system layers, kind of like file system partials, where something was run and there's a change, and then something was run and there's another change. So essentially a bunch of diffs that when put together, they make one cohesive file system. And what the storage drivers do is that they piece these things together for you. Now, unfortunately, we can't just have one driver to do this. That would be too easy. We have a bunch of different implementations with different trade-offs and reasons for wanting to choose one versus the other. So we'll kind of go through that. Now, what driver should I choose? I get asked this question all the time, and I literally, after this talk, you will not know from me, anyway, what driver you should choose. This is going to be up to you. You're going to have to weigh the trade-offs, what makes sense for you, what makes sense for the platform you're running on. So I've made this little chart. One column is type, where you can see we have essentially two types, file system and block. These type names aren't exactly accurate, but they at least let me segment the categories for you. Now, file system, the ones that are labeled as file system, essentially what happens is these sit on top of your existing file system and can expand and contract as needed for the workload requirement. Whereas the block ones, you have to pre-configure, pre-set up. You have to format it with Btrfs if you're using Btrfs. Tell Docker about the block devices and do all kinds of setup. And they have a fixed size. Now, certainly the file system ones have a fixed size, but that fixed size is the size of your root partition or whatever partition you're running Docker on. Now, both of these have certain advantages and disadvantages. For instance, all the block ones support disk quotas. And I don't know if y'all know this, but we have disk quotas in Docker now, which is in 1.12, you can fire up a container and tell it, this container is not allowed to use more than 10 gigabytes or whatever, which is pretty cool. And then I have this trouble column. This is not scientific. It's just basically the way I feel about these drivers, the way I feel about the likelihood that this driver is going to cause you an issue. You can see AUFS is a 1. This is because it works pretty well. It has had some issues over the years, but in general, it works. The bugs that it has are known, and for the Docker use case, they're not really a problem. That's not to say you're not going to have a problem, but you're probably not going to have a problem. Whereas Device Mapper is a 6. This is because, well, it's kind of hacky technology that's based on old stuff that will cause you problems. It has all kinds of options to tweak that might work for your environment and might not. So you are going to be very likely to run into issues. If for anybody in this room that uses Device Mapper, you will have to tweak these for your environment because you probably will run into issues. Now, Overlay and Overlay 2. OverlayFS is a new file system in the Linux kernel since 3.18. Overlay 2 is a driver that we just added to Docker for 1.12. Both these Overlay and Overlay 2 use the same OverlayFS. However, Overlay 2 takes advantage of some new features that were added to OverlayFS in kernel 4.0. And if you don't mind, I'm going to go a little bit of detail there, where in kernel 3.18, OverlayFS basically works. You can specify a lower directory and an upper directory, and it would merge them together for you. Now, you can only specify one lower directory. And as I said before, these images are a stack of file systems that we need to put together. So we weren't able to specify these multiple layers. So we kind of worked around that by taking a hard link against each one of these layers and merging those into our own custom lower layer directory. This causes a couple of issues, excessive inode exhaustion. So you might not be out of disk space, but your system is going to report that you're out of disk space because you're actually out of inodes. So if you're going to do the old overlay driver, well, you're probably going to provision the disk with essentially twice as many inodes as you normally would. Overlay 2 is able to get around this because kernel 4 allows specifying multiple lower layer directories. And we're just able to go ahead and mount those in like we normally would for like a UFS. And it turns out that ends up making it a lot faster because we don't have to create all these hard links, and we don't have to exhaust all the inodes and all kinds of other crazy stuff. And of course, we support ZFS as well. If you are comfortable with ZFS and know how to use it, and you don't mind not having kernel support, that's great. It's probably not going to give you any problems. It's been around for a long time. It's pretty cool. So how do you choose a driver? Probably the best way is this right here, where we have this JSON configuration file. This is actually relatively new, since like Docker 1.10, that you can actually specify the Docker configuration that's going to be used in a cross-platform way. And by cross-platform, I mean more like Red Hat versus Ubuntu, not Docker or not Linux versus Windows. Although this does work in Windows, but it's going to be in a different path, obviously. So I'm assuming here, of course, that there's nothing else in this JSON file, and that you live on the edge and you want to use overlay 2. And please do try out overlay 2, because we really need people to test it to kind of make sure it's good and works for everybody. Now, if you do change your storage driver from what you've been using, and you have been running containers and pulling images and stuff, when you change it, all this stuff is going to disappear, and you're going to freak out. This is because Docker can only use one driver at a time. Your data is still there. You just can't see it anymore. The way to see it would be to change it back. Then you can export your old images and then change it back to the new one, and you can import them in just fine. There's nothing to worry about, just something to be aware of. So that was, like I said, I'm not going to tell you which driver to choose. If you need disk quotas, then you need to choose Btrfs or ZFS or Device Mapper, hopefully not Device Mapper. Or if you don't care about that stuff and you want to be able to have containers that can be as big or as small as possible, use AUFS or overlay. They're all useful for different reasons. So persistent storage, this is probably why most people are here. Persistent storage, in Docker, what we call these are volumes. What volumes are objects that live, or I won't even say objects, they are places to store data that live outside the lifecycle of the container. So when you create a container, you tell it, I want to use this volume, I want to put it at this path in the container, so that when I write data to it and I remove that container, that data will still exist. And I see this all the time. And certainly, if you're looking to deploy Docker and you have stateless applications, it's probably easiest to start with stateless applications, because state is difficult to deal with. Stateless applications are super easy. You don't have to think about anything. And if you have only stateless applications, you can kind of live on your own little island and not care about anything. At my company, where I was, I didn't have a single stateless application, but I deployed my entire infrastructure on Docker. That was databases, web apps, Redis caches, even crazy things like VPN tunnels for OpenVPN or StrongSwan. All this stuff had its own state, and I had to deal with all that. Now, every developer, when you're writing a new application, or every developer can remember a time when you were writing a new application, and it was amazing. And the reason why it was amazing is because you didn't have to think about anything regarding state. You could fire up your application, push a bunch of buttons, and it was awesome because you could close it down and it would just be gone. It would be clean. You fire it back up again, you can push more buttons and run tests and not think about anything. And we push off having state for as long as possible. We push off the decision on having a database or writing to disk for as long as possible. But then the day comes when your manager says, OK, this thing needs to be shippable. People want your button clicks to be saved. And so we make that decision. Then we have all kinds of questions. How do I do something with Docker? How do I handle my backups? How do I migrate my data? How do I have a bajillion IOPS because we are super web scale? And when I get this question, I get it almost every day. My first response is, well, how did you manage that without Docker? Because one of the reasons I enjoy Docker so much is because it's so simple. There's no DSLs to learn. There's extremely natural syntax. You don't have to learn a new tool in order to use Docker. This is a really good example where we just basically say from Ubuntu and run some commands that are normally in Ubuntu. You want to build something, you can do a shell redirect right into the standard in of the build command, or you can echo stuff out to dev null, or you can even do crazy stuff like cat a file or a tarball inside the container and redirect that out to the standard out of the Docker client and have a tarball outside the container. It's all very natural. It's very shell-like. The command structure is based around having lots of shell substitutions. And if you use a lot of shell, it's just natural. And the reality is, Docker does not change the fundamentals of computing. I'm a Docker employee, and I'm saying that. Hopefully I don't get fired for saying that. But compute is still compute. Networking is still networking, and storage is still storage. All Docker is doing is moving the point of interaction up a step, so that instead of dealing with low-level infrastructure details, you're more dealing with the requirements of your application. For instance, you may say that your application requires an SSD drive, and it's like, well, you don't really need an SSD. You might need the extra IOPS that an SSD might offer. So we start to define our applications in terms of performance requirements and where you need to put stuff versus what things should be used to store that stuff. Containers are not black boxes, though. You can certainly get into the underlying nitty-gritty details if you want. All this stuff that make up the fundamentals of storage and computing and networking are still there. So when I see these things on Hacker News or whatever, which I made the mistake of reading yesterday, and there was a bunch of people saying stuff like this, I was getting fired up, I just started to go a little crazy. Because I was doing this 2 years ago, almost 3 years ago. Databases and VPNs and Redis and all kinds of crazy stuff. And I just get to the point where I just start to twitch, and I just feel like I have to keep myself from trying to correct this person. And it's not because the person is wrong, it's because they missed the point. The point of containers is not containers. The point of containers is to abstract away the infrastructure so that you can define your application and think about things in terms of your application instead of the infrastructure. And storage is hard. It's super hard. It's such a hard problem. Brian Cantrell from Joyent, and he did Sun and wrote ZFS and dtrace and all kinds of crazy stuff. He was just talking the other day about how, writing a ZFS appliance, they never lost anybody's data, but he said it took a lot of really long vacations. This is because storage is hard. Distributed storage is especially hard. So how many people here have lost their data? Maybe you had a RAID array that should be fault tolerant, something happens, and you go to swap out the disk and you put it in and it doesn't work. Your data is gone. Or you have pictures on your laptop and your kid spills juice all over it and your pictures are gone. But it's okay, you've got a cloud backup. Or you've got a local hard drive backup that your kid happened to knock on the floor 10 days ago and it's actually broken, you didn't realize it. Or you've got another backup RAID array that's been getting clone backups of all your other data, but you go to load it and the backup is gone. Or it just doesn't work. No, seriously, how many people? Everybody here. Storage is hard. So how does Docker handle storage? In general, it's very simple. We create a volume, and we give it a name. Now, the point of this name is so that you can reference it and do something like Docker run, say I want to use this volume that I created, and I want you to put it right here where Postgres writes data. And now Postgres, everything it does is going to write to this volume. Then I can remove that container and spin it back up with that same volume name, and we have our data back. But what if you want to use shared storage? Well, there are a number of ways to do it. One way, did you know, how many people here have used the Docker volume command? Almost half the room. Did you know that the local volume driver supports mount options? So just like you would type mount -t NFS, and you give the NFS path, you can do that with the local volume driver. So we're doing opt and type equals NFS, device is the location of your NFS, and then the export path. And then you mount that in the container right just like you did before in the same exact way. You give it the name and the path that you want it to go to, right, where Postgres maps its data. And then you run it, and then you take it away, and you bring it back, and your data's there. And you can do this on any host because it's NFS. And Postgres can write really, really slowly because it's NFS. What if you want to use Btrfs? That's cool. It supports snapshots and clones and all kinds of crazy stuff. Cool. Well, you can do the same thing. Type is Btrfs. Here's the device I want to use, /dev/hdb. And just like before, you just tell it where that container is, or where that container needs to write data, and it mounts it in, and you have a Btrfs volume inside your container. And you can do with it what you please. Now, these are super low-level details, and we have also a huge ecosystem of plugins. Every single cloud provider, I don't remember all the acronyms, EBS and S3 and GCE's stuff and Azure's stuff. You can use all this. Distributed block things like Portworx or Block Bridge. These are all really cool technologies. Gluster, Ceph. You can even do other crazy stuff like mounting a directory from a key value store and mount it as a file system inside the container. Or HashiCorp Vault. If you want to use secrets, you can take a Vault secret and load it right into the container. So, if you want to use a plugin, basically, you spin up the plugin, and the instructions will be on each of those plugin pages. And if you were in the last talk, you can see we actually have a command to install plugins, but I didn't show that here. You just specify the driver, that is Glusterfs, and just like everything else, Docker volume create --name important data, and boom, you can use that. And that'll, because it's Gluster and it works everywhere across the cluster, if you take a node down and your Swarm reschedules your container on another node, it can bring it back up right with the same exact data. So how do you do it with the new Swarm mode? It's actually a bit easier because you don't even have to do Docker volume create. You can specify those options right on the Swarm command. So this acts like a template. So if the container does get rescheduled, or the service does get rescheduled, Docker will know exactly how to recreate it out of thin air. So really, you can do anything you're crazy enough to do. You can put strong swan in a container, like me, and establish VPN connections to a bunch of 3G devices that we had out in malls, which was horribly slow, by the way. But be sane. And by that, I mean, don't store data directly on your host. Like, don't do host-mounted volumes unless you really have to. Most people don't really need to. Don't share state. There is a Go idiom, and probably other, just general. We share state by communicating. We don't communicate by sharing state. In the same way, things like volumes from are generally a bad idea. Well, one, it's not going to work on a cluster. And two, you now have two applications trying to vie for the same data path. And this might work on some file systems, and it's going to break horribly on others. And in reality, it causes all kinds of race conditions. And it's just a bad idea to try to share your state. So if you have a volume, have it in a single container at a time. So that was my talk. Anybody have any questions? Any questions? What's that?
If you can just please get up and line up, there's microphones on both of the sides, and just form a line and ask the questions. Thank you.
Hello. So you said regarding backup, how would you normally do backup without Docker? Does it make sense to say in Docker you could just back up all your volumes, and then, you know, whether you're backing up Postgres data or MySQL data or whatever, it doesn't matter anymore, and thereby you actually gain something with Docker, or is that a wrong assumption?
I didn't quite hear the question. There's a lot of echo. I'm sorry.
Sorry, must be because I'm hearing myself. I was just wondering, because you said that doing backups of data should not be very different when you're running Docker as compared to running anything else. Mm-hmm. But I had always in my mind that you could actually make backup very uniform. So regardless if you're running a Postgres database or any other database, for example, yep, that you could just back up your volumes and tell your IT guys you no longer have to be an expert on database XYZ. But is that a wrong assumption on my side?
No, it's not. So one of the things that's nice about this is Docker creates a uniform interface for interacting with these different volume types. And it basically just uses the virtual file system. So you can do two things. You can pick a storage solution that has a good backup story, or you can do it manually and load up the volume, run the backup, and unmount the volume. Now, for things like databases, backups are important. They are super important. But if you want something like high availability on a database, use replication. Don't use shared storage for high availability. I meant to say that earlier. Like totally, it's easy to set up replication these days. Yeah.
All right. Thank you.
Yep.
All right. 1, 2. Oh. So the question, two questions. They are somewhat connected. What will be the default driver? Will it change from AUFS to something else? Because AUFS is being dropped by some distributions, right?
Sure.
Well, yeah. What will be the coming on? Like, what will be the driver that will be default one? And another question, again, related to maybe AUFS, the garbage collection. I mean, there are scripts by Spotify, et cetera,
right,
but
right.
Probably a lot of people would, enjoy the native solution, sort of, because, clearing the varlib Docker every time, not a pleasant experience.
Sure, yeah. So in terms of AUFS, so everybody keeps saying they're going to drop it, but it's part of Ubuntu 16.04, so it's going to be around for a number of years now. That said, nobody likes AUFS. Like Linus will never have it in the kernel because it's complex and difficult. We're kind of all hoping that overlay works out. There are still some kernel bugs to deal with. That's like I never recommend overlay for people unless you're just in a development environment. But we kind of hope that that's the future, unless there's something better that comes out. The second question on garbage collection. Yes, we want to do it. Before Docker 1.10, it was very difficult to implement garbage collection because every single layer would show up as an image, and we would have no way to know what images you actually needed, because they were just, a million images because you had a million layers versus, 500 images and a million layers. I'm just making up numbers. So it should be a bit easier for us to implement now, but we're still kind of looking at how we might do that. Certainly there would be, garbage collection is hard no matter what, and trying to make sure we don't remove images that are in use or going to be used is certainly a concern. So, but yes.
All right, thanks.
Hi. In a Swarm cluster, what would you recommend to use for shared volumes?
What's that?
In a Swarm cluster, what would you recommend, what storage plugin, what would you recommend to use for shared volumes? So if containers have to mount volumes, and I want the same data to be shared in the entire cluster?
It's really going to depend on your use case. There are a few out there, some that do distributed block storage, that are all multi-host aware. There are drivers out there for every single cloud provider that are just going to work as well. It's going to depend. If you're on Amazon, I would recommend grabbing the one that supports EBS. If you're on Azure, get the Azure driver. If you're on none of these things and you're running in your own cloud, maybe you want to set up a Gluster or Ceph. It's going to depend on what you like and how much you want to manage infrastructure.
So right now, Docker provides like the overlay networking, which is great. So that basically makes the whole networking transparent in the entire Swarm cluster.
Sure.
Will it ever be the same with storage, so we can have some kind of overlay storage for the Swarm clusters?
Storage is hard.
I got that.
Storage is hard. That's all I can say on that. Right now, we really do lean on Docker has tons of storage partners to deal with this. There's half the floor out there is storage partners. And I would recommend checking them all out because they all have really cool technologies.
Okay, thank you.
Yep.
Hi. So my question is, say I have like a Python application that writes to like a database, and then I want to use Docker Swarm to scale up, and so it will spin up multiple containers that have the Python application. Then what happened with the database, or like how does it work?
Scaling up a database?
Yeah.
I would not use shared storage for that. Or I would make sure you're not using the same volume in every replica. So you're going to want to make sure that, currently you have to specify a name in order to specify the mount type in the swarm mode. So that's a good question. We'll have to think about that.
All right. Thank you.
Yep.
Another database question. So I'm loading in database dumps into a like Postgres or MySQL image to distribute for developers, so that way they can have fast startup of applications. But it seems not quite pleasant to disseminate a 10 gig database image because the databases are quite large. Is there a better pattern that you would recommend?
Yeah, keep the data separate. So have in the MySQL image what you're expecting to use in terms of configuration and what have you. In terms of things that's going to change, like your data, distribute it separately. So I wouldn't shoehorn your data, even though it's convenient. I wouldn't shoehorn it into the image. You're going to want to distribute that either on FTP or I don't know, just some whatever shared solution that you can put it on S3 or whatever from the download.
Okay, so just like the dump on there, just say, hey, you're going to have to wait for the dump to load.
Yeah, I mean they got to download it anyway, right? So.
Sure. Okay. Thank you.
Yep.
You said not to use host-mounted volumes, and I understand that would tie your container to that particular host, but are there other reasons not to use host-mounted volumes?
Yeah, so, and actually I would say I don't consider the host-mounted stuff as volumes. I specifically, I make an effort to make sure I don't say volume when I'm talking about the host mounts because they are not volumes. We have a volume object, and then we have host paths. I like to keep these separate. The reason to not, well, there's multiple reasons. One is that. Another one is we try to not affect the host in a way that we can't replicate. So right now, for instance, if you do docker run-v, you give it a host path. If the host path doesn't exist, it's going to create it. But what if you meant to do a file, but the file wasn't there? Well, you're going to get a directory, and it's going to try to mount that directory into the container, and then you're going to get all wonky. Just stuff like that. There's also extra features if you use a volume. Docker has the option to copy from the container image into the volume and populate it with whatever data you might expect to be there, like preceded MySQL information or what have you.
Okay. So it's not a reliability issue, just to be clear.
Yeah, it's extra management on the host level that kind of breaks down some of the container architecture. It's not the right word. It kind of pokes holes in your container that can cause other issues.
Okay, thank you.
Yep.
Which of the storage drivers is the most performant, do you think? You talked about which one was the most reliable. Which one do you think is the most performant?
For the graph drivers,
Yeah.
in general, probably overlay, with overlay 2 anyway. It actually has some nice caching in memory for sharing even across containers. You can share library, I don't want to say shared libraries, but sharing paid caches in between containers for things that are like similar libraries that are being loaded. It's pretty cool.
Thank you.
Yep.
Hi. I have a question. We plan put MongoDB in container just for fun, a replica set, and we use software RAID there, MD-Atom, with 2 volumes in AWS mirror. So how to not mount it, but just pass through devices so we can create actually the software RAID
Into the container?
inside of a container to run MongoDB process, on 2 volumes, so for high availability. Because AWS sometimes degrade volume, so we can easily replace it.
Okay.
But again, I know it's container, so probably some other solution instead.
Okay, I'm going to repeat that just to make sure I heard and understood the question. You're asking if you can pass through devices from the host into the container?
Yes, not mount them, but just use devices so we can create software RAID and then mount.
Yeah, so on the Docker CLI, you can do -- device and just give it the device path. You can pass either a directory of devices or a specific device.
Yeah, but looks in general not very good solution. So probably it's just secondary node, like more nodes, because container can fail. If volume failed, it will be hard to replace inside of container, right? Like to make this replacement procedure inside of container, like on casual server.
Are you saying if Swarm moves the container somewhere else?
Like if one volume failed from 2 and we want to replace it in RAID, sorry. One volume from 2 attached to container failed. We want to replace it. So it's manipulation inside of container. So probably it makes sense to create 2 nodes instead. I mean, what it suggests, what do you think?
Okay, so you want to take a device that was not previously in a container and put it in there to replace another device.
Failed one, yeah.
Okay, we do not support that yet. It's something.
Yeah, no, but we can write some scripts, but it does not say. I mean, it looks like not container way, not Docker way.
Yeah, there's actually a proposal on how we might be able to support this on Docker, or sorry, on GitHub. So we're actually looking into how we might update devices inside the container. Yeah.
Okay, thank you.
Yep.
Hey, yeah, so as you say storage is hard. So I'm not really an expert on databases.
Mm-hmm.
So would you consider saying that a good best practice would be to use a batch service for an application? Or maybe say that in general terms, most applications could just use batch services, and by that I just mean like some database connection over TCP or something, and using like Mongo or MLabs or using some Amazon-hosted database service versus just maintaining my own databases inside of that. And I was just, what is your opinion on those?
Yeah. If your company is willing to let you do RDS or whatever, great. I wasn't allowed to, so I didn't do that. But yeah, I don't see any problem with that. If you don't mind having data in the cloud that you don't own.
Do you, other than security issues, do you see negatives to that approach?
Latency, that would be about it. Yeah. One more?
Sure. This is a question about a pattern that I've been using that you sort of said might be a bad one, so I'm curious. You said volumes from was probably a bad idea. However, I've been teaching myself Docker. However, people have been using volumes has kind of baffled me because I thought that volumes from was a great idea. I've been using ephemeral containers for the services. And then instead of pointing directly at a data store or a backend, I was pointing at an actual container that was dedicated to storage, and then just using volumes from to that. That way, anywhere that they popped up in the swarm, it didn't matter because they all knew to go to this container on this set of hosts that was just for containers that were going to be for storage, using volumes from to manage that and use one API to manage how the volumes, so I could focus on in terms of what the storage backend was. Well, that was all managed by these container volumes. Is that a bad pattern?
It is, so using volumes from to essentially store references to volumes is kind of, well, it was kind of used. I mean, I wrote an article a couple years ago that a lot of people reference on doing that, encouraging people to do that even. And the reason why we were doing that is so that when you create a container, you could actually be able to reference those volumes again after you remove it, because basically what would happen is you would create a container that has volumes, but we didn't have a volume command, a subcommand to figure out what volumes you had. So when you remove a container, the data was still there, which is great, but you couldn't find it because there was no reference to what that volume data was.
Well, that would have been in the compose file. I mean, I found it best because I could just commit that volume. It's just for mail store, so I could commit the volume periodically, push it to the registry, and have my backups without having to touch the service. But it sounds like that's a bad approach. I would say, so you're wanting to make sure you can co-schedule two containers together, storage and your application, right? Yeah, it's a cohesive system, right? So like, I'm not going to bring up the containers without the storage container, or it won't know where its data is. So it's when Docker compose up, it says, oh, okay, well, I'm going to start these services here, and I'm going to look for this service here, which is just storage.
Yep. I would say we're lacking a feature to make that happen in a better way. So not that what you're doing is bad, but what we're doing is bad. And we need to make sure that we can support your use case to make sure you can have storage and schedule to it.
Great, thank you.
Cool. I think that's all we got.
Thank you, Ryan.
everybody.